One thing that I love about calculus sometimes is you start with some so obvious common sense ideas and come up to really cool facts. Okay? If you picked the minimum value between two places, which in this sense happens to be at the beginning, and you pick the maximum value between those two places, which is sort of in between A to B, closer to B here. Brilliantly, you can say the following, that the actual area, right, this integral in the middle, this is the actual area from A to B, has to be bigger than the rectangle made with the smallest value, and smaller than the rectangle made with the biggest value. Brilliant, right? Like, I think that is extremely obvious, that if you took the smallest rectangle and the biggest rectangle, the actual area would be somewhere in between. Okay? Then, as you go through all the rectangles, all the way through, it's continuous. We've got sort of an intermediate value theorem idea here. If you started with a smallest rectangle and checked all the values as you went up to the biggest rectangle, somewhere in there, there's going to be a point C that's exactly the same as your rectangle. So this is saying that there exists some point C in between A and B, that if you did the rectangle with that point, it's exactly the same as the actual area. And this, if we just take this formula and divide both sides by B minus A, that point where the area is perfect is actually the average of the function between those 2 points. Which is kind of like if you wrote 10 tests and I asked you to find your average, you would add all 10 up and divide by 10. But when we're finding an average of a function, there's an infinite amount of points. Can you imagine writing an infinite amount of tests? You're like, no, it feels like you do that to us all the time. I'm constantly working on a quiz or studying for a test in this course. Yeah, so if you wanted to find your average after doing an infinite amount of assignments, well, you'd have to add them all up. That could take a while. And then you have to divide by infinity, which is kind of hard to imagine. But now this becomes the average of a function, which is pretty cool. So from 0 to 3, what is the average of 4x cubed plus 2x? There's got to be a point C. There's got to be a point C on f of x so that the area is that height, f of c, times by a minus b, or b minus a, sorry. So we find our integral, b minus a happens to be 3. We find the area of that rectangle, which is an easy integral to do. Plug in our values. And the average is 30. If you just looked at this graphically, it'd be like, how do I figure that out? It starts at 0, it ends at 90. If it was a perfectly straight line, we'd be able to say the average would be 45, going from 0 to 90. But it's not a perfectly straight. Sorry, was that too quick? Yes. Good. So now we got x cubed minus 2x plus 4, interval from -1 to 2. Find the average value of f. So again, the distance is 3. We find the integral multiplied by 1/3. And again, you guys are good at the numbers here. Add 1 to your exponent, pretty easy integral. Of course, if you had a calculator, these questions would be really easy because you just type that value into your calculator, get the integral right away. In fact, on your calculator, I'll just show you. I'll type it in beforehand here so that you can still see. So on my calculator, I typed in -1 to 2. I typed in the integral. Again, you can find the integral button by hitting the math button and going down to number 9. So I type that in. I push enter. I get 12.75. I divide by 3, and I get my 4.25. Or I could have, if I was thinking ahead, I could even have done the 1/3 out in front and then written this and got the 4.25 directly. So I could get my answer really quickly from my calculator. I always find on these average ones that I'm like, ooh, I have to do the integral, and I hit the integral button, and I'm like, oh, I forgot the 1/3 out in front. I usually have to divide by 3 afterwards because I went to the integral button first. I mean, you could use your cursor and insert it in front too, but either way will work fine. Now find all the values on C such the average value of f is equal to f of C. So here's our equation, x cubed minus 2x plus 4. We found out that C was 4.25. If we graph our function, 4.25 was our average, and between -1 and 2, you can see that it hits more than once. It hits at -0.126. It also hits at 1.473. It also would intersect here at -1.3-ish, but that's outside of our original. We were looking between -1 and 2.